everyone. Thanks for joining us for this week's Weather Extra. I'm First Alert meteorologist Jillian Johnson. Throughout the past week, we had a thick plume of Saharan dust to fill across our skies. For more on the dust and how it impacts the tropics, we bring in First Alert meteorologist Sean Bellafiore to kick things off for us. Sean.
Temperatures continue to warm up this past week across central Texas, but of course the big story was the hazy skies thanks to a plume of Sahara desert dust moving in midweek. And take a look at this. I want to show you what it looked like on visible satellite. This is what it would look like if you were looking down on the Earth from space. You see all of that haziness across the Gulf of Mexico and Texas's Gulf Coast on July 30th. That dust plume, of course, moving its way into central Texas. This is what it probably looked like outside your door Tuesday at 6:30. We didn't really notice too much of the haze, but by Wednesday at 1 o'clock, those skies were milky and gray, all thanks to that plume of Sahara desert dust. Now, one thing the Sahara desert dust does is it helps to suppress tropical storm and hurricane activity. It is one of the reasons why we have seen such a quiet July after Hurricane Beryl moved into Texas, and outside of the tropical system moving into Florida this weekend and early next week, another big plume of Sahara desert dust is going to be moving across the main development region of the Atlantic, which should keep the tropics mostly quiet. But it is still expected to be a very active hurricane season. NOAA expected to update their hurricane season outlook over the next couple of days. We've already had 3 named storms, 1 hurricane and 1 major hurricane. But sometimes we have to look at a little bit of a different metric to determine how strong these systems are in any given hurricane season. And for that, we turn to ACE, the acronym, which stands for Accumulated Cyclone Energy. It's a mathematical formula, not too complicated. The sum of the wind speeds in a tropical storm or greater in knots every 6 hours times 0.0001, just to make the numbers a little bit more manageable. Now, ACE is a really helpful way to determine not only if a hurricane season is active, but how strong those storms are. In the Atlantic Basin, 2020 and 2005 are tied with 30 tropical storms and hurricanes, 30 named storms in a year, but 2005 is the only one on that ACE list. It's very high up because we had a lot of very powerful storms. And I wanted to point out, this is an X or a tweet, a post from Brian McNulty, who is with meteorologist with the University of Miami. Now, we have had a very quiet July, but because of how strong Hurricane Beryl was, the amount of ACE we have accumulated would be considered average if we had no other tropical storms or hurricanes until August 31st. Reporting in the studio, Sean Bellafiore, KWTX News 10.
Another major weather story from the past week was that crews were battling nearly 100 large active wildfires across the nation. And according to the National Interagency Fire Service, the U.S. is at preparedness level 5, the highest that exists. Some of the blazes are still growing in size and even turning deadly. Amy Kelly reports.
Harrowing evacuations are underway for humans and animals as almost 100 large active wildfires rage across the country.
We are at planning level 5. That's our highest level of fire response.
Colorado officials report at least 1 death. It's linked to the Stone Canyon fire.
We do have a lot of law enforcement resources staged here and also on standby that if we do need to do additional evacuations, we can ramp up quickly and get people out of harm's way.
The state's also battling the Quarry Fire. It's spreading rapidly.
We have a rattlesnake problem to deal with, so we have a lot of things to be concerned about for our firefighters today.
And Colorado faces the Alexander Mountain Fire.
We have evacuated about 4,000 people on a mandatory evacuation and another 800 involuntary evacuations.
In California, the Park Fire remains the biggest challenge. Its burn mark now spans almost 400,000 acres. That's bigger than the city of Los Angeles. Rescuers are saving people and pets from harm. These dogs are repaying the favor, offering therapy to those who have lost everything.
Ordering people out of their homes is always a tough thing to do. We recognize that the anxiety and the trauma that visits upon people.
I'm Amy Kiley reporting.
Take a look at this. Severe thunderstorms rocked eastern Nebraska and southwestern Iowa Wednesday evening, causing widespread power outages across the Omaha metro area. At one point, more than 250,000 residents were left without power. A powerful bow echo slammed parts of the Midwest region with hurricane-force winds, resulting in extensive wind damage. The airport in Omaha, Nebraska recorded wind gusts of 90 miles per hour. And devastating flooding has wrecked parts of the Northeast last week. Strong thunderstorms brought heavy flooding rains to Northeast Vermont this past Tuesday. Some areas received more than 8 inches of rain, which caused roads to wash away, crushing vehicles and pushing homes off their foundations. Vermont officials say at least 50 homes were destroyed or suffered significant damage. 24 boat rescues also occurred. Flooding has been taking place across parts of the eastern half of the nation like this past week here, just like you saw. In Tennessee, Dollywood reopened on Monday after heavy rain caused the flooding at the Pigeon Forge Resort. Last Sunday, the flooding was so severe some visitors couldn't leave the resort. But as Jared Austin reports, some guests say it was a memorable experience.
We have a raging river here.
Dollywood visitors left stranded for hours dealing with flash flooding.
So we didn't really understand the gravity of the situation in the moment.
Rainwater rushing through the streets of the park.
It was just torrential rain. It just would not let up.
Lindsay Brindle with her kids there Sunday night, feeling a little helpless.
We were seeking shelter and kind of making our way slowly but surely towards the exits. But by the time we got to the exits, things had really just gotten to a point where we had to stay. We were stuck.
A day after the heavy rain, it's almost back to normal. Sounds of rushing rainwater, now just sounds of water from the water wheel.
I mean, literally in less than 12 hours, the maintenance team was able to go through, repair a section in the parking lot, and clean this entire park up.
Pete Owens with Dollywood saying the city and parks infrastructure can't handle this much rain. They're also fixing parts of the parking lot where water appeared waist high at points.
We'll evaluate what happened and whether or not there are things we can adjust so that we can make things better. But, you know, that's a 100-year flood in an act of God. So we'll have to see exactly what adjustments that we can make moving forward.
As for park goers, there's no ill will to the park, just some memories.
Was a core memory for my kids.
My 6 and 9-year-old, I don't think they're going to forget it anytime soon.
Coming up in this week's Degrees of Science, Brady Taylor spoke with the leading oil field related earthquake expert about the science behind why we're seeing earthquakes in parts of the Lone Star State. More on their conversation when we come back. Welcome back to Weather Extra. On Friday, July 26, one of the strongest earthquakes in Texas history struck parts of West Texas, and it was one of over 100 earthquakes that occurred within 9 days. Brady spoke with the leading oil field related earthquake expert to find out more about the science behind these recent quakes. Take a listen.
Dr. Hennings, I guess the first thing is, do we know if this uptick in earthquake activity is natural, or is it more induced earthquakes that are taking place?
Good morning, Brady. It's our assumption that these earthquakes are human-caused, and they're related to the other earthquakes that have occurred throughout the Permian Basin region around Midland and Odessa in the last few years. That area near the county line between Scurry and Fisher, it's not known for natural seismicity. The pattern of the earthquakes and the relationship to human causes in the oil field are very similar to what we've seen in many other cases in the Permian Basin region.
So how exactly would be oil field activity, how is that impacting and causing earthquakes across Texas?
All right, let me back up a little bit on that. So earthquakes come when you have an existing geologic fault that slips. And geologic faults, of course, do slip over geologic time and make earthquakes. In West Texas, there are many of these geologic faults in the subsurface. They're many millions of years old underneath our feet, down in the ground, you know, maybe 10,000, 15,000 feet underneath us. If the stresses around those faults become unstable, those faults can slip in local areas and slip small amounts, and that gives us earthquakes. Those faults can be made to slip if we change the stress state around them. And it's pretty easy to do that. These faults exist in rock that has fluids in the rock, and those fluids have a pressure, a pore pressure to them, like pressure in a bicycle tire. And if you increase that pressure near a sensitive part of a fault, and other conditions are also satisfied, you can cause that fault to slip and make an earthquake. And one way to do that is to inject fluid back into the subsurface and increase the pore pressure in the rock near the fault and destabilize the fault. One way is by hydraulic fracturing. The process of extracting oil from unconventional reservoirs, which is so prevalent now across Texas, especially in West Texas, involves drilling wells down into the ground and then turning those wells and drilling them horizontally. And they can go a couple of miles horizontally through the rock. Then, to make the rock deliver the oil to that well, the well is called fractured, hydraulically fractured. And from the surface, the way that's done is water and sand and some other things are pumped down the well at high pressure that causes the rock in that horizontal part of the well to break in regular intervals. They call them stages, and fracture the rock. And then those fractures will extend away from the well into the rock. In rare occasions, that hydraulic fracturing itself can interact with these existing faults. And since that hydraulic fracturing is a pressurization process, it can cause a fault to destabilize and make an earthquake. But that cause is a much rarer cause of human-induced earthquakes in these petroleum regions. What's much more prevalent is that water that comes back with the oil as the oil is produced has to be disposed of. And the common practice for disposing of that water is to inject it back underground in other wells to dispose of that water permanently in subsurface formations. It's that process that is very widespread. Thousands of wells across the state of Texas do this every day, that then in some places can cause an increase in the pressure and faults to slip. There are pilots underway in the Permian Basin region to filter and treat this produced water for what's called beneficial reuse. Maybe this beneficial reuse could be used for crop irrigation, to assist with livestock production, even to recharge natural drainages in surface water flows. But we're a long time away from that because this process of filtration and treatment is expensive and it's slow, and it doesn't now handle the kind of volumes that could offset this huge volume of water that's produced every day. And I guess the last thing to note on that is in the Permian Basin, every day the petroleum industry has to handle 15 million barrels of this wastewater, and most of that is injected back underground.
Well, that was just part one of Brady and Dr. Peter Henning's conversation. On the other side of this break, we'll continue their conversation and dive deeper into the kind of work that's being done to learn about these oil field related earthquakes and how to prevent them in the future.
So we've had a lot of news about this. Is there a trend that we're seeing of more of these induced earthquakes happening across the state of Texas over the last few years or decade?
Well, there certainly has been an increase in the last decade. In Texas, as the unconventional development of shale basins became prevalent, beginning in the Dallas-Fort Worth area and the Fort Worth Basin around 2008 and 2010, there were injection-induced earthquakes there, but those earthquakes ended once the rates of this injection and disposal went down as that petroleum system reached its ultimate life. Then the activity of an increase in earthquakes shifted out to the Permian Basin region as that region economically started to develop all of its unconventional resources. So beginning in 2017 and 2018, we saw the rates of these earthquakes increase out in the Permian Basin as well. And those rates increased to a maximum in 2021. And what we've seen is the monthly rate of those earthquakes was the highest then, and it has come down since then from that peak. But there are pockets or clusters, we call them, of earthquakes that occur or kind of pop up in unexpected areas, like the one last week, where the rates just get higher in a localized area. But it seems pretty straightforward that the process of injection is the most likely cause. And as this injection moves out in other areas of the Permian Basin, such as happened for this cluster that we recorded last week, we will see new areas of earthquakes from time to time.
So one thing I really thought was interesting with your work with the Bureau of Economic Geology is kind of the partnership that y'all have with not only the public sector and the research side, but working with these petroleum companies. How does that help to learn more and potentially help stop this activity?
Yeah, appreciate that question. Our center is funded by a variety of sources, and one of the sources is by sponsorship of the petroleum industry. And we have 30 industry sponsors who provide us funding on a yearly basis, and they look to us to do research that helps understand the specific causes of these human related earthquakes, these induced earthquakes. The Center for Injection and Seismicity Research is collaborative between the researchers in the center, the industry, and the regulator, because we're also funded by the Railroad Commission of Texas, the New Mexico oil and gas regulator, and also at the national level. I mean, everybody is pulling on the same end of the rope here, trying to understand what the causes are so that these practices can be made more sustainable. In a given area, if injection causes a lot of earthquakes, the Railroad Commission then requires these injection well operators to suspend their activities, which is an economic loss, investment loss, and it's just not what anybody wants. So what the industry wants and what the regulator wants is that the industry is as sustainable as possible, and the creation of induced earthquakes is not a sustainable thing. And so this collaborative that sponsors our research has these aims to understand where and when the earthquakes are most likely to occur so that the industry activities can be as sustainable as possible and mitigate the chance of causing those earthquakes down, which has happened successfully in many cases thus far in the Permian Basin region.
You're talking about kind of learning where they're happening and get ahead of it. How much does it help having the TexNet mapping ability now that you're getting observations all over the state and maybe catching some of those small ones to learn about before a big one happens?
Yeah, well, having the TexNet earthquake catalog is probably the most important aspect of all of this. That's the state-funded seismic network that's operated out of the Bureau of Economic Geology, and that earthquake data is the enabling thing that helps us understand where the earthquakes are happening, how those trends are changing over time, and that data gives researchers and the industry and the regulator some proactive ability to see how things are changing over time and space to try to get ahead of it and to do a more thorough job of mitigating the earthquakes where we know they exist. That data is absolutely essential.
To hear more about these recent earthquakes and the research being done to help prevent more in the future, scan the QR code on your screen to watch on YouTube or head over to our website at kwtx.com/degrees of science. Weather Extra will be right back. Welcome back to Weather Extra. July 20th marked the 55th anniversary of the Apollo 11 moon landing, and NASA is training the next generation of space cadets in the same area where the first astronauts once trained. Mason Carroll is in Flagstaff, Arizona, and has more on why this specific area is used.
Well, it's been 50 years since the U.S. sent an astronaut to the moon. In fact, every astronaut that's ever been to the moon has trained right here in Flagstaff. And now NASA is back in the high country, getting the next generation of space cadets ready for their trip.
Using Flagstaff as this tipping point to get back to the moon.
The rocky, otherworldly landscape of Flagstaff's volcanic field brought NASA's Apollo team to Arizona in the 70s.
One diathlete for mankind.
Now, NASA is back again. This time, the Artemis team is using the moon-like surface to train.
We bring astronauts from their very basic training in geology all the way to crew members that are going to go to the moon back here to Flagstaff, just like Apollo did. They set the precedence, and so now we're standing on the shoulders of giants.
Astronauts use training suits in the volcanic field here to simulate full moon walks.
Talked to Mission Control the whole time, and within Mission Control, the science team is there. So exercising all those components together is not something we can do very easily anywhere else. So here's where we can kind of get that done.
This trip to Arizona not only showcases the astronauts' training, but also all the technology used to create a real lunar experience.
Is giving an over-the-shoulder view of everything I'm doing. So if I'm in the field practicing geology, something like that, the team back in Houston and the Mission Control team can actually see what I'm doing as I do it.
Astronauts Kate Rubins and Andre Douglas sported the suits this week. They'll become the first woman and person of color to walk on the moon.
To be here in Flagstaff, where all of that training took place initially, to be doing it and realizing that 50 years in the future, our children and our grandchildren are going to be looking at these black and white photos, and that's going to be the team that got Artemis to the moon.
They say as they make history, they also want the next generation to shoot for the stars.
Liftoff.
And beyond.
Do what you love, that's the core of it, and do well in it, and then share your goals with people, and they'll help you get there.
Now there is no set date for when they will be blasting off to the moon, but astronauts will definitely be back here in Flagstaff to train in the near future. Reporting in Flagstaff, Mason Carroll for Arizona's Family.
That's all we have for you on this episode of Weather Extra. We'll see you again next weekend. Have a great week.